everyone, thank you so much for coming to this video. So today we're going to be going over how to solve differential equations. So make sure you go over the videos on integration and the different methods we need to use for that, and also how to integrate different functions, as that will come into use for this video. So the learning objective for today is to be able to evaluate first order differential equations involving separating variables. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So the first thing you need to know is what actually a differential equation is. So a differential equation is just any that has the derivative dy over dx in it. And if it's in a context, it's normally something that it has like a rate of change. So rate of change is the same as like dy over dx. So the first step, so I've written the steps here to solve a differential equation. So if we try it with an example and go step by step, it might be more useful. So the first step is you want to write the differential equation in the form dy over dx equals f of x and g of y. So the first thing we want to know is we want to try and find our f of x and our g of y. So our f of x, that's just 1 plus x squared, and our g of y, that's just 2y. So now that we've got our f of x and our g of y, we can now rearrange the equation to get all the terms with all the terms with y on the left-hand side and all the terms with x on the right-hand side. So if we do that, we have dy over dx is just equal to 1 plus x squared and 2y. So now we want to rearrange this to get our y's on one side and our x's on one side. So firstly, if we multiply everything by dx, we'd get dy is equal to 1 plus x squared times 2y times dx. And now to get our x's on the right hand, to get our y's on one side, our x's on the other side, we can divide both sides by 2y, so we get 1 over 2y dy, and that would just be equal to 1 plus x squared dx. And now we want to integrate both sides. So if we do that, if we integrate 1 over 2y dy, that's same as a half of the integral of 1 over y dy. And now we want to integrate 1 plus x squared. So we could do this using a substitution, with our u being 1 plus x. So we could say that's equal to u squared. We need to, if we do du over dx, and that would just be 1, and then that means our du equals dx. So we just want to get the dx on one side. So then we can sub in that u squared du. Now if we integrate this, we'd get a half. If we integrate 1 over y, that's just ln y is equal to, now if we integrate this, if we add 1, we'd get 1 over 3 u3 plus c, and now we just want to plug in our u back into this, so we'd get a half ln y equals a third times 1 plus x to the power of 3 plus c. And now we can either rearrange it or just leave it like this. And we want to try and find our particular solution. So we want to plug in our y equals 4 and our x equals minus 1. So if we do that, we get a half ln 4 is equal to a third. 1 minus 1, that's just so 0 cubed plus c. So that means c is just equal to half ln 4, which is just the same as if you do, same as ln 4 to the power of a half, which is just ln 2. So now we can rewrite our whole particular equation as saying, let's do it over here. So it'd be y is equal to have a half, sorry, let's try this again. So we'd have a half ln y is just equal to a third 1 plus x cubed plus ln 2. And then if we multiply everything by 2, we get ln y is equal to 2 over 3, 1 plus x cubed plus 2 ln 2, which is just same as saying ln y is equal to 2 over 3, 1 plus x cubed plus ln 2 squared, so plus ln 4. And this is our answer to our question. That's the particular solution to our differential equation. So let me just go over all the steps again. So we first want to recognize that we have two functions, one of x and one of y. And then we just want to rearrange the equation to get all the x terms on one side and all the y terms on another side, and then integrate it. So we wanted to integrate 1 over 2y dy, and then integrate 1 over x squared dx. So when we did that, we integrated the y side as half ln y, and our x as 1/3 1 plus x cubed. So I did this by substitution. You could have easily spotted this. You could have easily spotted the substitution in your head, or you could have multiplied out, whatever's easier for you. And then remember to add your constant to the end, so that's really important. So if it was a general solution, we would have left it like this. But then because they've asked for a particular solution, you want to plug in your values of x and y to find your c. So when we did that, we got our c equals ln 2, and then we could just rewrite our whole equation and like simplify it to make it as ln y equals 2/3 1 plus x power 3 plus 4. So let's try another exam style question to see if you've understood this. So I have an exam style question here. Feel free to pause the video and try it out for yourself first. So we have, given that y equals 8 at x equals 1, solve the differential equation dy over dx is equal to 9x plus 6 times y to the power of the third over x, giving your answer in the form y squared equals gx. So the first thing you want to do is we want to write our equation in the form dy over dx is equal to f of x and g of y. So we'd have our f of x is equal to 9x plus 6 over x, and our g of y is just equal to y over a third. So then we have dy over dx is just equal to 9x plus 6 over x times y over a third. And then we want to rearrange this. So if we divide both sides by y over a third, we'd get 1 over y to the power of a third dy is just equal to 9x plus 6 over x dx. And now we can integrate both sides. So we'd get this can simplify to y to the power of a third dy, and then we can simplify each term of the expression. So we'd get the integral of that equals the integral of 9x over x, that's just 9, plus 6 over x dx. Now we can just integrate both sides here. So we'd get the integral of y to the power of minus a third. So we want to add 1 to this. So if we do minus a third plus a third, that's just 2 over 3. And then you want to do 1 divided by 2 over 3. So we'd get 3 over 2, y to the power of 2 over 3. And that's just equal to 9x, the integral of 9, so that's 9x, plus the integral of 6 over x, that's just 6 ln x plus c. So now we can plug in our y and x values to try and find out what our c would be. So then if we do 3 over 2 times 8 to the power of 2 over 3 is equal to 9 times 1 plus 6 learn 1 plus c. So then if we do 8 to the power of 2 over 3, that would be 4. So then if we do 3 over 2 times 4, we would get that is equal to 6 is equal to 9 plus 6 learn 1 is just 0, so equal to 9 plus c. So that means our c is just equal to minus 3. And then we can just rewrite our equation. So we'd have 3 over 2 y to the power of 2 over 3 is equal to 9x plus 6 ln x minus 3. And we want it in the form y squared. So we need to try and rewrite this to get y squared. So firstly, we can multiply everything by 2. So we get 3y power of 2 over 3 is equal to 18x plus 12 ln x minus 6. And now we want to divide everything by 3. So we get y to the power of 3 is equal to 6x plus 4 ln x minus 2. And now you can rewrite, if I do it over here, you can rewrite y equals 2 over 3 to say that's same as y to the squared or to the power of a third. So now we just want to cube this whole thing to get rid of the thirds. If we cube both sides, we'd get y squared is just equal to 6x plus 4 ln x minus 2 cubed. And that's your answer to this question. So you just want to follow all your steps, find out what your f of x is, your g of y is, then separate your variables to have all your y variables on one side, all your x variables on the other side, and then you can just integrate as normal, both sides, integrate both sides, plug in your x and y values to find what your c is, and then just rearrange, manipulate your expression to make sure it's in the form that they give you. So yeah, a lot of people will just misread, like just skip that. So make sure you do read that so you can get all your marks. And yeah, again, remember your constant c because you need that to when you have to plug in your y equals 8 and x equals 1. So that's everything. Thank you so much, everyone. Hope you found that useful and you can now evaluate first order differential equations. So make sure you do some practice questions to make sure you fully understand how to do this. As the more questions you do, the easier you'll get. So make sure you do a lot of practice.